Okay, we have arrived to renaming a relation. Guess I want to check the videos. Um, Recordings, database, fundamentals. We have arrived to calculation. We have arrived to projections, and we didn't talk about renaming. Or we have talked about renaming, I guess. So we have talked about renaming. So today I'm going to just remind you what's renaming. So the renaming operator is that one. The notation is that one. The renaming operator allows to rename relations and attributes. So either we change the name of the attributes, the columns here, or we change the name of this relation. So imagine here we have this relation R, and the name is name. This is the relation schema, name and bonus by basic salary plus bonus. So the degree is 2. It consists of 2 columns, and cardinality 1, 2, 3, 4, 5. So from 5 rows. So this is the relation that we call R. It was projection name on name and basic salary plus bonus on the previous relation employee. So we changed the number of employee to R. The table employee stayed as the same, but for this new relation, the output, this one, we call it R. So it's R, and it has this relation schema. In this here, a row or renaming operator allows to rename relations and attributes. The relation is this one, from R to result, and attributes from name in the previous table to employee name, and from basic salary plus bonus to salary. So we will convert this to something, or we will convert this to rename this as this. So it can expressed by one of the following renaming attributes and relations. A row renaming as B1, B2, Bn on relation R is a relation renamed as based on R. So the output of this operation will call it as, which is based on initial relation R, with column names, and we will call these new names B1, B2 to Bn. Okay? So we'll change the names of this, for example, to B1, B2, Bn. And the name will be S. So now this is to change the relation, the table name, and the columns of this relationship. Where here, row SR, we only change the name of the relation. So it's a relation renamed S based on R. And S has the same column names as R. So we didn't change the column name as here. The third case, row B1, B2, Bn. So this is we change both name of relation and attributes names. Here we change the relation database name, relation name, table. Here we only change the column names. Is a relation which doesn't specify a name. We didn't specify here to change, to rename this name to something else, but with column names B1, B2, Bn. Okay? So to change this previous relation, we call it R. And remember, here we did the same. So the output of this on this table employee provides this table, this relationship. If we want to change this to result, and if we want to change this and this to employee name and salary, what should we do? We just use projection. We add employee name, salary as here. So this will be the new attribute name and attribute salary. Okay, and we will call it as we will have this. So instead of doing this immediately, we immediately call employee name salary on employee, and we will have here result as here. Okay, so a relational algebra query is a series of operations applied to the database relation. However, if we want to apply several relation algebra operations one after another, we can write the operation as a single relational algebra expression by nesting the operations. One depends on nesting, it means that one depends on the another, and the another depends on the another, and the another depends on another, and so on and so forth. Or we can apply one operation at a time and create immediate result relations. And then in this case, we must give names to these relations. This I will clarify these things in an exercise today. Okay, so relational algebra query. This is an example. Imagine that here we want employee ID, first name, last name, salary, department number. To find first name, last name, and salary of all employees of the department number 5, we must apply a restriction and a projection, always the case. We use selection or restriction and then the projection. So we can write a single relational algebra expression as follows. We project, because we want specific columns from this employee example, we should use project, last name, projection, last name, first name, salary, and we want all these to be applied on department number of 5. So first of all, you select all the rows from this database, from this table or relation, where salary is equal to 5. Select the part number equal to 5 on relation employee, and then on the result you do projections. Okay, this is the first example. Here we use this one expression here, nested expression and operational, but here this is this case. First thing, how to do this? First thing, you can use this alone as here, and you call this relation, the new relation is employee department 5. After having the table, this table alone, then you create projection, last name, first name, salary on this data relation, and then you rename the new resulting table as a result. Now we'll talk about binary operations. As we've talked about yesterday about unary operations, it's for selection, projection, and renaming. But for the union, intersection, minus, and the cross product, we need at least two relations, R1, R2, or R and S, to execute these operations. Note that in the first three, union, intersection, minus, they need R1 and R2 must have the same schema. Same schema, the same list of these things. So R should have the same and R1 and R2. But R and S in the cross product is not necessarily to have the same schema. So can have different schemas in the cross product. So R1 union R2, R1 intersection R2, R1 minus R2. So R1 and R2 should have same schema here, same number of columns, 3, 3, for example, and same order of domains. Domains, it means type, data type. So for example, number, varchar, varchar, number, number. To do intersection or union here, or R minus 1, R1 minus R2, okay, to do this, R1 and R2 should have either the same list here, the same relation schema, or if this is F name or L name or family name, but the most important is to have the same order of data. Yeah, it means that the first one is integer, and the second one is integer. Varchar is in second, varchar number number. If R, this is R1, imagine. If R2 has here ID, salary, first name, last name, salary, department D doesn't work because they don't have the same order. The order should be int, varchar, varchar, int, int. They may have different column names, as I told you. They may have different. The result of this operation